So very good morning guys, welcome back to NEET World. So in this session we are going to concentrate on the JEE Mains PYQs. Okay, like yesterday we have stopped with some questions. Now we'll start with the questions where we left, right? Yes, I guess this is the question. Okay. Three equal weights A, B, C, each having of mass 2 kg are suspended on a string that passes over fixed frictionless pulley. The arrangement is such that they form a continuous hanging system, which given in the figure, shown in the given figure. So what is the tension in the string connecting the weight B and C? So I need to find what is the tension acting over here. Right, this is the question. So first we will draw the free body diagram. So yesterday I said to do this question as a homework. I don't know how many of you done. Okay, like whoever done, we'll check the answer and we'll cross verify it. Right? Okay. Now the free body diagram for A. Yes, this is my block A. And the tension here is T1, let me take. So here it is M1G. Okay. Now let me take the block B. So tension will be here. The same string, same tension. No, this is T1. So what about here? M2G is there, but one more tension is also acting, that is T2. Why? Because I am taking T2 is when string or rope changes, tension also changes. So the tension here is T2. Now the block C block. So here it is M3G and the tension away from the body, this is T2. So these are the free body diagram of the given diagrams. Now if I assume that mass is 2 kg, right? This is 2 kg and this side is 2 plus 2 4 kg. Obviously the block will move in this direction, right? Acceleration will be in this directions. So if I assume that acceleration is in that direction, the equations will be like T1 minus M1G, no, M1G, like what is mass? Like everything having equal mass, that is 2 kg. So this is 2G equals to 2A. Equation number 1. What about the equation 2? Like it is moving towards down. So what is the, like whatever the forces are in the direction of acceleration, I should write them first. This is T2 plus 2G minus T1 should be equals to 2A. That's it. Now what about the block 3? This is equation number 2. Equation 3 will be like 2G minus T2 should be equals to 2A. This is equation 3. So from this 3 free body diagram we got 3 equations. So I need to find the tension in between B and C. It means I need to find T2, right? So what I should do is I need to eliminate some values and I need to find some value. Like here I can eliminate G, I know that is 10 I can say. But T1 if I add, it will get cancelled. T2 if I add, it will get cancelled. So can I add equations like equation number 1 plus equation number 2 plus equation number 3. This is the step I am doing here. So it means I will take the pen. Yeah. T1 cancelled off, T2 cancelled off, and 1 2G cancelled off. So remaining will be 2G equals to 6A. Which means A will be equals to 1 by 3G or G by 3. That's it, no? So A I have taken in terms of G. So now substitute the value either in equation 3 I can substitute. Now equation 3 if I substitute I can get the value of T2. So 2G minus T2 equals to 2 into A is G by 3. So G by 3, which means 2G minus 2G by 3 equals to T2. So the final answer will be looking like 2 3s are 6. 6 minus 2 4. 4g by 3 equals to T2, which means 40 by 3 answer. That's it na. If I take G as 9.8, okay, or if they have mentioned you can take 10, you can take it 10. So T2 will be equals to 40 by 3. This is the answer. This is the answer for this question. Okay, we'll move for the next question. Next part of the question. Yes, if it is clear, we'll go. So only thing is, whenever the diagram is given, draw the free body diagram for those diagram and then write the equation. So thing you should remember is draw the free body diagram and I need to find which direction the acceleration is acting. So in that direction, what is the forces are given, I should keep in positive. The opposite direction of the acceleration, like the forces in opposite direction of the acceleration should be in negative, should be equals to whether it is moving, I should take mass into acceleration. It's not moving, 0. That's it na. Fine. Okay, we'll move to the next question. Okay, if an external force F is applied on a block of mass m at an angle theta with the horizontal as shown in the given figure, then for what value of F will the frictional force between the block and the wall become 0? So the frictional force between the block I should get as a 0, no? So if I take this diagram, I need to take the components first because it's making some angle theta. So let me take the components first. Yeah. So this is my F cos theta. So when theta is near, I can take it is cos theta, away from means sin theta, no? So this is my sin theta, F sin theta, is it? So I should not take like this, no, I should take this is cos theta and this one will be my sin theta. Yes, this is my sin theta. Yeah, F sin theta, no. So downwards will be my, yeah, I'll draw here. So make it clear, I'll draw here. Okay. So this is my angle making theta with F. So obviously the block is having the weight mg. Okay, mg. Now I need to find it. That's it. I need to find, that's it, no? Yeah. This is my sin theta, F sin theta, and this is my cos theta, cos theta. So F sin theta equals to mg. So F will be equals to mg by sin theta. That's the answer. When you take the components, obviously almost the answer has been completed. Yeah, why I have taken mg? Because when I take the frictional force, no, in this case, if I take the frictional force here, see, if I take the frictional force like mu is there, so I can assume it's a frictional force is there. So frictional force is equals to the mg, no, it is at rest, they have said, it is at rest, which means the mg and the frictional force should be equal, right? So that's why F sin theta equals to mg I have taken. So F will be equals to mg by sin theta. Which option? Option, yeah, option B is the correct answer. We'll go to the next question. Okay. So linear momentum P of a particle varies with time as follows. P is equals to A plus BT square, where A, B are constant, the net force acting on a particle. So one thing we know that like momentum is nothing but force into time. I will write that first. So what they have said, we know that momentum is equals to force into time, and they have said that linear momentum of a particle varies with time, which means F is equals to P by T is the formula. So one thing, like they have said that it is momentum is varies with respect to time, which means F is equals to dP by dt. Now the equation is given equation, so we need to get P with respect, I need to differentiate the P with respect to dt. So if I differentiate this term, what I will get, dP by dt will be equals to A, if I differentiate constant 0, B T square 2BT, right? No. So what they have asked, where A and B are constant, the net force acting on a particle, okay, proportional to T square, 0, constant. Now write the value of dP by dt here, F is equals to 2BT. So these two are constant. Now I will keep as it is. Now what they have said, F is directly proportional to T we got. So proportional to T square, 0, constants. So constant won't come, 0 was not coming, and proportional to T square is also not there. Option A is the correct answer, proportional to T. So the thing is here, momentum equation is given, I need to differentiate with respect to time, and then I need to substitute the value F is equals to dP by dt in this equation. I need to take the constant, keep it as it is, and whatever is there I need to take it proportional. So I will get the answer for this question. Yes, Humang Mishra, there is the answer. Option A is the answer. Yeah, we will go for the next question. Okay. So two blocks of masses 2 kg and 1 kg are in contact with each other on a frictionless table. So note this point. This table, when an horizontal, so it is table, when an horizontal force of 3 Newton is applied on to the block of mass 2 kg, the value of the constant force between the two blocks is, so the value of the constant force between the two blocks, which means both the blocks are in contact with each other, there will be a normal force, right? When a block is contact with some other surface, there will be a normal force. So I need to find the normal force in between them. Okay, that's the question they have asked. So I will draw the free body diagram first here. So free body diagram for the mass m1, that is 1 kg, no, 1 kg, right? Okay, this is m1. Okay, this is my normal force n1. Okay, n1. So my weight is acting towards down, m1g. Okay, now any other normal force is there? Yes, because there is a contact between them. No. So if there is a contact between them, I need to draw one more normal force, that is n2. So these are the forces acting in block 1. When I take block 2, this is my block 2, that is m2. So now the forces, if I see here, this is, okay, this is, I will take the normal n. Okay, now I will take this one as n2. Okay, this is my m2g. Now force is acting, right? Now force is acting, like someone is giving external force. So in this direction, F. One more normal force is acting in this direction, that is the same, whatever force is there in this opposite force, then only the block will move together. So normal force. Now if I apply a force in this direction, in which direction the block will move? In this direction the block will move, no? So this direction the acceleration acting. So this is my acceleration direction. Now what I told, so whenever the force is there in the direction of acceleration, I should take in positive, the opposite direction should be taken as negative, and if body is moving should be equals to the mass into acceleration of the given block. Now I will write the equation for this. So first for this I will write, so in the direction, no, so first n is equals to, is it visible, or I will take the pen yellow, okay. So n is there any opposite force? No, nothing, should be equals to m1a. Keep it as it is, this is equation 1. For the block 2, if I take, F is in the direction of A and N is the direction of opposite to A, which means F minus N is equals to, F minus N is equals to M2A. Done. Now I need to take this as equation 2, okay. Atharva, yes, we are doing for chemistry also, man, it will be there. Yes, so okay, up to now, like as of now you listen this and give answer for this question, we will see. Okay, so this is for equation 2. Now if I see here and if I consider this is equation 1 and 2, if I add these two equation, no, what I will get, n and n will get cancelled off, F will be equals to m1 plus m2 of A, okay. Now from this I can find m1 they have given, m2 they have given, and the force also they have given, right, force also they have given, which means, yeah, force is nothing but 3 Newton. 3 divided by, what is the mass, 2 plus 1, 3 equals to A. So A equals to 1 meter per second square, this is A. So either I can substitute the value of A in equation 1 or else equation 2 to get the normal force that is acting between the block M1 and M2, which means N is equals to, what is M1? M1 is 1 kg and it is acceleration is 1, which means 1 Newton is the answer, okay. Answer is 1. Option D is the answer. I hope you got the method what we have used here, right? Guys, whoever watching in online also, if you have any doubts you can ask and give comment in the comment boxes, we will clarify it. Okay, we will go for the next question. A block of metal weighing 2 kg is resting on a frictionless plane. It stuck by a jet releasing water at a rate of 1 kg per second at speed of 5 meter per second. The initial acceleration of the block is, okay. What they are asking? I need to find, yes, I need to find the acceleration of the block. So we know the formula, right? Yeah. Where's the question? Yeah, this is the question, right? I will give a hint here, like we should use the formula force equals to mass into acceleration. So acceleration will be equals to F by m, okay. Now try to give the answer, we will see. I will give 30 seconds time. I'll say this also, like m is given and they have said that 1 kg per second, right, 1 kg per second, which means I can write this F as again mass into acceleration, right, mass into acceleration, which means they are saying that like it is releasing at the rate of which means dm by dt. Okay, dm by dt. So kg no mass, seconds no time. So at the rate of dm by dt, which is equals to 1 kg no 1 kg per second. 1 kg per second. Now like mass I have taken from F is equals to ma, I have taken the mass. What about the acceleration? Acceleration, can I write it as v by t, v by t. So can I write this as v into dm by dt, v into dm by dt. V is they have given speed, so can I write like this, v into dm by dt divide by m, that's it, divide by m. So if I take m and m will get cancelled, v by dt will be equal to acceleration. So left hand side and right hand side are equal. So from this, speed is there 5 and rate of water that has been released, it is 1 kg per second and weight is 2. So which is nothing but 2.5 meter per second square is the acceleration, guys. So option A. So don't ever think that like where we will get the formula, like we need to understand the question and derive the formulas. Okay, so here I'll explain you once again, whoever not listened. So block of a metal weighing 2 kg is resting on a frictionless plane. It stuck by a jet releasing water at rate of 1 kg per second. So whenever they are giving the units now, first try to find what units they have given. They have given kg, which means mass. They have given seconds, which means time. So mass by time they have given. So okay, mass by time they have given dm by dt, because it is rate releasing at a rate. So dm by dt it is 1 kg per second, right? Now at the speed they have given v is equals to 5 meter per second. The initial acceleration they have asked, that's it. So we know that F is equals to mass into acceleration. Acceleration will be equal to force by mass. So again force can be written as same, mass into acceleration. Like mass I have taken as it is, but acceleration what I have taken, v by t. So here it is, I have taken like mv by t, but it's only m and t are changing. V is speed 5 meter per second square as it is. So that's why I have taken dm by dt as 1 kg per second and v I have taken as it is divided by m. So I'll get the answer for this question. Okay, we'll go for the next question. Yes, a body is projected at an angle of 30 degree to the horizontal with kinetic energy of 40 joules. What will be the kinetic energy at the topmost point? Okay, at the topmost point they were asking, no? So what should I do? So they have said that the kinetic energy, initial kinetic energy, guys, this is, so which means kinetic energy is equals to half mu square. So half mu square is nothing but 40 joules. I'll keep as it is. When it is making an angle 30 degree with respect to horizontal, which means at the topmost point, no, velocity will be u cos theta, no. So kinetic energy at the topmost point only they have asked. So what can I do now? So Ke at t, topmost point, will be equals to half mu cos only, no, cos theta the whole square. That's it. So what I can do here, 1 by 2 mu square cos square theta. So mu square is nothing but 40 and cos square theta, what is cos square theta? Like cos 30, no, root 3 by 2. root 3 by 2 the whole square. So 3 by 4 will come now. 40 into 3 by 4. 1s are 10 times and answer will be my 30 joules. So when it going up at the topmost point, kinetic energy was 10 joules. How much energy has been lost? For like 10 joules for 30 joules, 10 joules energy has been lost, like it has been converted to either kinetic potential energy, right? Potential energy. Okay, we'll go for the next question. Next question. Okay, two blocks of mass 10 kg, 20 kg are connected by a massless spring placed on a frictionless surface. A constant horizontal force of 200 Newton is applied on a block, 20 kg block. At the instant when the 10 kg block is accelerating at 12 meter per second square, what is the energy stored in the spring? So we will write first what is the formula for energy stored in the spring. Then I can write whatever the given terms there, okay. So energy stored in the spring is nothing but E is equals to half kx square. E is equals to half kx square. This is the energy stored in the spring. Now write the things whatever they have given. Two blocks of mass 10 kg, 20 kg connected by a massless spring. So 10 kg is there and it has been connected with massless spring and 20 kg block placed on a frictionless surface. So they have placed on a frictionless surface. A constant horizontal force of 200 Newton is applied on a 20 kg block. I have applied 200 Newton on 20 kg block. At the instant when 10 kg block is accelerating, 10 kg block is accelerating at 12 meter per second square. What is the energy stored? Understood na? So we have drawn the diagram whatever they have given. Okay. So F is equals to 200. What is the force? Spring force. Kx, no? Fx equals to Kx. Kx. Here what they have given? K they have given, no? 2400, like 2400. Now equate it. Force. Same force only, no? If I apply, opposite force will be there. So which means 200 equals to 2400 into x. I can find the value of x from there. So this 2 zeros will get cancelled. 1 by 12 equals to x. Yes, no? 24 coming this side. 1 by 12. That's it, na? So x, this is the value of x. Now take the value of x and substitute here. I will get the answer, no? E is equals to half 2400 into 1 by 12 the whole square. 1 by 12 the whole square. So it is ones and it is 12. 1200 into 1 by 144. So if I calculate this, I will get the answer for the equation. I will get the answer for the equation. Right? Okay. Okay guys, we will stop up to this. Okay, we will continue with the next class. So everyday physics class, JEE mains questionnaire sessions will be at 11:30 morning. Okay, so don't try to miss these classes. It will be very useful when you solve the questions. Okay, we'll meet you in tomorrow's class, guys. Bye bye. Bye bye bye.